Okay, here's my walkthrough of the recent schema with core.logic. Here is, I was just at my membero. That succeeds if X is an element of the proper list L, or X is an element of the list L. So my membero here succeeds. Then here it will succeed with the first element because this goal will succeed. So this will just be humus with Peter, and here it will be nothing. This will just not succeed. Yeah. Then here this is funny because it kind of goes through all of them. So we say that this succeeds, but then we keep going, and there's more things that can succeed because this is the disjunction. So if you run it, if you find all possible outcomes, you will actually just get the list. It's kind of interesting. Then here it's just that. Also, this is an improper list, so peaches doesn't show up because peaches is just the element by itself, but if I call first on the element, then I don't get, well, it's not a list, it's just none of these succeed. Because it's not a list, this doesn't succeed, so peaches doesn't show up, but if it's a proper list, it shows up. Then here we make a logic variable, and this time we have the logic variable in the list, and of course, this will succeed if X is E. So it works this way around. This is the same. Is this the same? I'm not sure why I have this twice. Then my membero E in this list, yeah, then X is still fresh because E will be, my membero will succeed because it will find the E, and then this goal will succeed, and X will still be fresh. We never assign X to anything. And if the ordering is changed, this has an effect. So, because we walk the list recursively from start to end, we actually assigned E to this. And interestingly enough, if we find all possible things, we see that there are two solutions. Either X is E or X is still free, because my membero has a solution where E is this E, but it has a second solution because X can also still be E. So either X is still fresh or X is E. And yeah, now we do the same thing with two logic variables, and there's two outcomes where either of them is E and the other one is still fresh. Okay. So I'm gonna continue here. I was pasta. Oh, I wrote, I have a typo in pasta. What did we do with run x e? With run x e, and then here, well, yeah, we go through the list and we say that e is not equal to this. So we check if the rest is has the member e. And then we find E and we are done. Yeah. So then we say that, yeah, this goal succeeded and it succeeded. Also in the run star version of this, you say that, I don't know how the engine works, but we say that we keep running until we find all possible solutions. Yeah, it's actually interesting. I guess it says that X is allowed to be E but I'm gonna keep looking. Maybe there's another solution or something. We filled a blank in the list so that membero succeeds. Yeah, which is funny. Here the ordering method, and here we find all possible solutions where either of them is E. What is each value in the list? There are two values in the list. We know from frame 60 that the first value when E is associated with X succeeds, leaving Y fresh. Then we determine the second value. Here E is associated with Y, leaving X fresh. Okay, what is the value here? So I'm gonna type everything so that I learn how to type. This is always useful, I think. X, Y. Okay, now I'm gonna say equal, and then there's the list. Pasta, X, fagioli, and Y. That is equal to Q. Okay, so we are making Q the list of this. Okay, and now we say that membero E is membero of Q. Yeah, okay. This is not. Oh, fagioli. Oops. This is not actually different. Oh, Y was at the Y is at the thingy position. Wait. Why do they get this out? So either this is still fresh. Either the tail is still fresh, yeah. Oh, I forget to make this a proper list. That's the problem, I think. Yeah, okay. Actually, this had infinite solutions, I think. Okay, so here it says pasta E. So we say that X is E fagioli, and then Y is still fresh. Yeah, okay. Or the other way around. Okay, this is the same. This is basically the same as what we just had, but this time we make more assignments. We just have this Q as a middle thing in the middle. Okay, what is the value of run 1? L. Also L. Also membero. My membero. Tofu L. Okay, this is a list of the element L and then still fresh somehow or something. L is yeah. And this fresh variable, this is basically this D here, because here I say fresh, right? This variable needs to come from somewhere. It came from this D. So it succeeded that L was X. And how does this work? Actually, how does this work? L is the first thing in L is X. And so actually it's not this D. It's not this D. Yeah. It's this D that comes from this first O. Yeah. So it only goes into this goal, and it says that there exists a D where conso ADL is is L. Well, yeah. So basically it assigns a fresh variable here, D, and this is the one that I see here. So it says that there exists a tail of a list where if the list is L, then the first element is tofu. which lists are represented by tofu? Yeah, okay, yeah, this is every list where car is tofu, yeah. Because we say that there's a fresh tail, it's kind of everything's still possible, yeah. Except that the first element is tofu. What is the value of run everything member tofu? Yeah, this is, I think this print, like this basically, yeah, okay, it just, they have something that makes it stop at some point, but yeah, this would be all possible lists where, anything is tofu. Any position is tofu. It has no value, but this actually has no value. It's because everything's still possible or something. What is the value of run 5? Okay, these are all lists of 5 elements where any of those elements is tofu. Yeah, and the rest is still unspecified because it's basically because of the fresh D here and the fresh D here that basically we allocate fresh variables. So these are the ones that show up. And then we say it's tofu and then the rest is still fresh. So we constrain the list, but we don't constrain it by, we constrain it somehow. We constrain it a little bit. It's a list where tofu is a member. So it's quite interesting. So I guess at some point you would figure out how to program with this and you would understand, here I'm making a constraint and then I'm layering in the constraints and then the solutions are sort of the overlaps of the constraints or something, I guess. Or the conjunctions, probably. Tofu. Tofu is in every list, but we can require each list containing tofu be a proper list instead of having a dot before each list final reified variable. Can we this to be a proper list? Can we require this to be a proper list? Let me think. Wait, I can constrain the list further to say that it is a proper list. So I can say that there exists a D and then that resto of L is D and that D is nil, like this. Oh, this never ends. That was not good. Oh no, what did I do? That was not good. Oh, it's still running. Oh no. Okay. You can run infinitely. Yeah. Do I need to do this before? Does this matter? Now I'm a little bit scared. Run 5. Wait, why did this never end? Resto LD tofu. I think now I fixed it. Okay, there's only one solution. So yeah. I already narrowed down D to be nil. Okay. This was not the solution. This narrowed it down too much. It's kind of like I want to first say this and then this, but then I have an infinite thing. So I don't know how it works. Perhaps this final reified variable appears in each value just after we find tofu. In membero, which cont E line associates tofu with the car of a pair? Always this one. First to LX. It says that it says conso, and conso makes an equal here. That says that the first element of L is X and that these two are associated. The first line. What does membero first cont E line say about the coda of L? It says that it's fresh. I need to go into the definition, and here it says that D is fresh. Is a fresh variable. Nothing. This is why the final codas remain fresh in this frame of L. If the coda of L is the empty list, is L a proper list? Yes. If the coda of L is beat, is L a proper list? It's a if the coda of something is a list, this is also a proper list. Suppose that L is a proper list. What values could be L's coda? Lists, proper lists, any proper list. What values of L can be codas? What codas can be values? I need to say that L is a proper list. I need to say that D is a proper list, not this, not empty, but proper, propero. And what is proper? Something that has listo here. Listo. This says it's a proper list. So this, I need to say listo, and then I still leave it open for something else. So D is listo. Wow. Okay, now I narrowed it down to the proper lists. Yeah. Wow, this makes sense. Amazing. Okay, cool. Yeah, of course. Wow. Okay. Now I layered in two more complicated constraints. Yeah, in this constraint. Yeah, okay, well, yeah. Once you wrote a constraint, you also don't need to think about it. The same way you don't need to think about functions in procedural programming. I mean, listo just works. This is really cool. Actually, I don't even need to say that D is a list. I can just say listo, because here I think let me try. I think I can just say it's a proper list. It's the same output, yeah. Cool. So here I said that I still left it open how many elements there are, but I said that the last element is an L. Else it doesn't succeed. Else it doesn't succeed, because one of these two needs to succeed. So either there's a rest where the recursive call is true, or you are empty. So okay, very cool. Here is proper membero. Okay. Okay, let me write this. Proper membero. This is X and L. Then cont E. So let me look at membero again. Okay, it's kind of this. But here I also say listo. Wait, I just say well, this would work. Listo D, they say coda LD listo D proper member. They say it here. They say here that if we can assign X to L as the first element, then there's another goal where there's D. This is actually what I wrote here. But you don't actually need this. But yeah, fresh, then you say resto and then listo. Yeah, that would be this version, yeah. Like this. So there's the That's the second goal. They differ with this additional constraint here. When first two succeeds, then fresh. This goal also needs to succeed, where we say that the rest of L is a proper list. The coda of L in the first condy line of proper member must be a proper list. Now, what is the value of run 12 proper membero tofu L? Run 12 L proper membero tofu L. Yeah, this is all proper lists where tofu is an element, and everything else is still open for interpretation, I suppose. And it's just the first 12 lists. Tofu. Oh, it keeps on going. It doesn't even put the tofu at the second position. Only here it does. And this is interesting. I guess this has to do with the details of the execution flow, basically. Why does it end up basically trying out making the tail longer, and then it puts the tofu there? How does this decide to do this? I'm not sure. Every list is proper. This is true. Is there a function proper member we can transform and simplify into a proper membero? Let me think about this. The scheme code. I have a scheme here. I can actually say run geyser, and I actually have a scheme REPL running. That's kind of cute. Okay, let me think about this. Define proper member proper member question mark. Okay, it takes an X and an L. Okay, case 1, X is the car of L, and L is proper. Case 2, proper member of the coda of L. Okay, so that one is easy to write. This is coda of L and then proper member X, like this. Case 1, and L is proper. How do I say L is proper? I need to say list, right? I need a function called list. Does it exist? This already exists. A list of this is T list of this is false. Okay, so this checks if the input is a proper list. Yeah, okay. So this line gets translated into list question mark. And here I need to say the coda of L. Yeah. And the other thing is that car of L is equal to X. I hope this is the correct equal function. Is this also a function? And no, this is not a function. And EQ equal. There's EQ, EQV, and equal question mark. There's also EQ hashcode, equal recur, equal always, equal contract. Okay, I use this one. I suppose I'm just this is I don't actually I'm not actually a racket or scheme programmer, so I don't know. Bad syntax. Also, this needs another. Then it's true, and then it's true. And else it is false. False. Like this. Proper member. Tofu of a list where the first element is tofu. It's wrong. Given tofu, expected number. Also, equal is only for numbers. Hey. Okay, I'm gonna check here. Equal. And okay, I see here I forgot something. Oh, does this will no? I think my version will just work because of this additional clause I have here. So they don't have that clause. Yeah, and this is actually an error. And wait, the symbol nil is not a thing in scheme, I think. Okay, here it's true, yeah. And then if there's a symbol, expected pair given a car. Also that's why they have this earlier out here. Okay. If null f then false. Okay. Oh, I'm wrong. What? One sec. I was just wrong. What? What am I saying? If car L, but the car L is not a list. Also, I can change this to be tail recursive by doing this. Okay. This doesn't help me right now. Also, you don't need to say and. You can collapse it into the cont. Equal car L x list coulda L. Okay, now I have almost the same thing. If null L false. What the hell? Oh, now it works. I accidentally, I'm not entirely sure what I did. Oh, I didn't. I don't know. But yeah, okay. No, I actually just have this version. No, okay. Okay. Now go make a cashew butter and marmalade sandwich and eat it. Man, this would be funny if somebody is actually doing this every time. I need marmalade stains. But this is also a little bit challenging with this PDF. Okay, next chapter called Double Your Fun. Double your fun closure. Okay, this was the tofu and membero kind of stuff. And here I go to double my fun with this ride thing, and there's like they're all together, like they're all pairs. They're double, like there's one rhino and then one lion, and they're all two lions. And here's another rhino or whatever, and another bird. And this is wait, I think that this thing is a tapir. Yeah, I think this guy is a tapir because he has this snout. How do you call this thing? What they have? Nose trunk. They have a trunk. Prehensile is the name. So prehensile means appendage. So prehensile just means appendage. Yeah, tapir. I don't know. They're cute. I guess they're funny because they're actually the closest relative to elephants. It doesn't say here. They're similar to pigs. Tapirs inhabit jungle and forests in South and Central America and Southeast Asia. Yeah, okay. They are one of 3 extant branches of the Perissodactyla, the odd ungulates, alongside equines and rhinoceroses. They are odd-toed ungulate. Am I even true with this elephant story? There's only a single genus, the Tapirus, is currently extant. Tapirs migrated into South America during the Pleistocene epoch from North America after the formation of the Isthmus of Panama. Okay. Cool. Pleistocene is quite recent, I think. As part of the Great American Interchange. Oh, funny. I also didn't know about that. Tapirs were formerly present across North America, but became extinct in the region at the late Pleistocene, around 12,000 years ago. Okay. Probably humans hunted them and they died in North America. Tapir is Portuguese. That means old tupi, or going back to specifically the term tapira. This word, according to Eduardo de Almeida Navarro, referred in a more precise manner to the species Tapirus. Oh, okay. Why did I think that they have anything to do with elephants? They go to the Tapiromorpha. Tapiromorpha. These are the odd-toed ungulates. That includes these guys with the horses, I suppose. And here are the tapire, and here are the rhinos. I'm just completely wrong with this story of the elephants. What the fuck? Why did I think this? I was so wrong. Holy shit. Elephant are in the proboscidae. They're just completely different family. It's so funny. So they are in the proboscidae. Proboscidae. These are the animals with trunks, I guess, or something. Proboscis, from ancient Greek, proboscis, elephant trunk, are all Afrotherian mammals containing the living Elephantidae and several extinct families. This is a family with only the elephants. And their close relatives. The 3 living species of elephant are African bush elephant, forest elephant, and Asian elephant. Extinct members are the Deinotheres, Mastodons, Gomphotheres, and Stegodons. Okay, they're all kind of elephant-like animals, I guess. The family Elephantidae also contains several extinct groups, the mammoths and the Paleoloxodon. Include some of the largest known land mammals with the elephant and mastodon mammoth. They have body masses surpassing 16 tons, rivaling or exceeding Paraceratops. Long-limbed hornless rhinocerotoids lived until the end of the Oligocene. They represent some of the largest terrestrial mammals that have ever lived. Okay, so here Elephantidoide, Proboscide. These are all kind of extinct, I guess. Oh, this one is not so big. There's a human here. 12 elephants, that's kind of funny. I was so wrong with the tapir. That's so funny. It includes the Sirenians, Proboscideans, and the extant order Embrytopolia. What are the Sirenians? These are the sea cows. Oh, okay. Okay, I still think that this guy is probably a tapir. This is a rhino giraffe. Oh man, how do you call this? Zebra, elephant. Wait, this is a rhino and this is a hippo, and this lion. Okay, just training myself. Here's append. Okay, I'm gonna go to a scheme file called append scm, and then I already have guys are running. Yeah. Okay, so I'm gonna write append. Yeah, already exists, but I can overwrite. So L and T, a list and an element. T, a list and actually, how does append work? I have a list and then an element. So this would add it as a non-proper list. Okay. Oh, this doesn't work. So okay, that's what append is. So that says that. Wait, how does this work? Cons. 1 sec. Okay, now I'm looking at how they do it. After all, all right. Okay, so there are two ways how this succeeds. Either oh wait, either L is null. Also, okay, then it's just the list. Okay, and then otherwise it's the first element of L, and then const that together with. This is actually kind of tricky. I don't think I would have figured this out right now. Append with the rest of L. Also, yeah, the recursive call with T. And it says that the first element of A, make a list, basically make a list where the first thing is the first element of this list, and the rest is append with this. Okay, so I'm basically building a list. And this is the non-tail recursive version, where basically we build a list of like the elements of L. And then we put, so we kind of put T as sort of the cons of this new list that we make. So we basically kind of find the last cons and put B there a little bit. Okay, now I have this version like that. Okay. What is the value of append A, B, C, and then D, E? This is A, B, C, D, E, the list A, B, C, D, E. For a different approach to append, see clause and effect. This is a whole book. Also page 59. Okay, append something with the empty list is just a proper list. Because then this immediately succeeds. No, wait, this builds the list, and then T is then the rest of the new list. Yeah, this is basically what we say. We kind of say that T is the rest of a list where all the cars, all the successive cars are kind of added. Yeah, it's we say what the rest is with append. That's kind of funny. Okay, so if I write append A, B, C, and the empty list, this is just, also this will be a list where, oh wait, what will, it will just be the proper list, A, B, C, okay. Why is it not this? Wait, why is it not this? Because it is actually this. No. This would be different. It is not this because I say cons append T is the empty list. Also because L, also this way I kind of replace the rest with this. So I replace the rest with this. That's why. It's not that I append the rest, but I replace the rest, kind of. And because L is a proper list, it will basically, change what the rest of the list is. Well, yeah, the rest of the list, because it's a proper list, it's kind of a list. Okay, what is the value of append? Just the empty list with DE. That will be the list DE. Like it must be the list DE. There's no other way. What is the value of symbol A? DE. Wait, das doesn't work. Okay, it's just an error. What is? It has no meaning. Yeah. What is the value of append? DE and then A. Yeah, this is also fine, but then it's not a proper list anymore. Yeah, then A was the rest, the new rest. It has no meaning again. No, the value is D, E, and A as the rest. How is that possible? I know how this is possible. swaps the T for the rest kind of here. So when you say append coulter L, and L is the rest, the empty list, then this thing becomes T, and then cons with something, with a list and something, yeah, also makes improper lists. So that comes out of that. Look closely at the definition of append. There are no cont line questions asked about T. Ouch. You think that is not good? You wanted to say here that if T is... okay, let's see. Here's a translation from append and its simplification to appendo. Okay, let me think about this. W of 1, okay. So I'm gonna say appendo. Appendo also exists in core.logic already. So I'm gonna call it my appendo. I don't know why I override it. I guess I override. Okay, so appendo XL.